enjoy especially renewable power stations.
Okay. Hello, everyone. We just started in 2 minutes, and yeah, welcome to join our Bitcoin Heat Day. Yeah, so many friends here. Yeah, and some of them are on the way, but yeah, we will start in 2 minutes. And I suggest if you want to try some fruit juice, yeah, you could just get from the outside the door, the corner. It's really healthy. Yeah, you could choose that. And about the fruits, yeah, we are open to serve you any fruits, anything you want. Okay, and we will start in 2 minutes. And thank you for your join. Yeah, it's a good day, and everyone joins here because we take. I think we take 1 week to find the best place to hold the Bitcoin Heat Day, and at last we find this place. Everyone can feel here that it's just like we have a meeting in nature. Yeah, so the hotel, their theme is sustainability, and also our theme is sustainability. So we choose that, and also you could see so many plants inside the hotel. When you come into the lobby, there are so many plants. So maybe I think in the future we could just build more buildings like this, and to give you a feel like you live in the forest, live in the nature. And also we provide the fruits, provide the vegetables, and provide the juice. All these things we provide. And maybe next year we hold the same Bitcoin Heat Day. The fruits, the juice will come from the heat from the Bitcoin. So that will be really important. Yeah. So, okay, I will start today's event, and yeah, the Bitcoin Heat Day. So, good afternoon, everybody. So, thanks for joining us to our Bitcoin Heat Day. My name is Arthur Lee, the founder and CEO of SAI. We just listed on NASDAQ. Yeah, there are so many friends here, and it's my great honor to hold this first Bitcoin Heat Day in New York City. Yeah, it's a really important city, and we want to start from the 3 parts. We will have 3 parts in today's event. First, I will just give you a speech about our solution for our industry and the future of the heating we use for Bitcoin mining. And the second part will be the ESG, our ESG analyst, Patrick. He will just introduce our ESG strategy and the industrial trend. And the third part will be the networking time. So for all our guys, we could talk more details, cooperations, everything. We could talk about that. So before my speech, I know everyone here, I think there's someone here knows that Bitcoin Pizza Day, right? the day that someone used 10,000 Bitcoin to exchange for a pizza. And I think that will be the most expensive pizza I've ever heard. So yeah, it's really expensive for now. But Pizza Day is for memory of the first transaction. But there are 2 tracks on Bitcoin industry. The first is trading, and the second is mining. So mining is the fundamental. So we think that why not to find a day to celebrate the mining industry for the Bitcoin? So yeah, we find that Bitcoin Heat Day, and I will tell you why we choose the Bitcoin Heat Day. Pizza Day, and this year the Pizza Day, I saw the activities organized by Binance. They just sell pizza, and even the founder says he just sell the pizza and deliver the pizza. So I think for Heat Day there will be some difference because actually I like pizza, but I think fruits, vegetables, and juice will be healthy. So why not choose more fruits, more food that based on Bitcoin or have the potential to based on Bitcoin. So I will give you more details about our solution for our total industry and even for the computing industry. So next, I will just allow me to introduce the distinguished guests first. There are so many friends here, but sorry, I can't got enough time to just introduce all of you. But I want to introduce Mr. Stephen Churchill. And he's a strategic leader with broad experience in public and private sectors and the nonprofit area. And Churchill served as the chief of staff at the U.S. Embassy in Beijing. And he also working side by side with the ambassador to advance the embassy's strategic priorities. So next, let us welcome Mr. Churchill. Yeah. Thank you.
Yeah, Arthur, thank you. Well, thanks, Arthur, and thanks for inviting me to join you. It's exciting to be here as a part of the Bitcoin Heat Day, and I'm really honored to be in New York City. I first met Arthur at a meeting of entrepreneurs in Detroit and was really impressed. I was with Ambassador Branstad at the time, and so I'm glad that we've been able to maintain our contact. And we were really impressed just from the outset with his energy and his focus and his drive and your real vision for something that can be a really great solution for the United States and for people across the world. I'm hoping to learn more today about his vision like you are, but Ambassador Branstad and I are really convinced that energy is an important sector and that the work that you're doing can really be an important contributor to help in the Midwest where we're from, but also throughout the United States. So thank you for the important work that you're doing. I do want to take a moment to introduce Ambassador Branstad. I met Ambassador Branstad when I was a college student, and we've worked together on 7 different occasions. He served as the U.S. Ambassador to China from 2017 to 2020, which was really an interesting, dynamic period of time in the U.S. Bilateral relationship with China. He also holds the distinction of being the longest serving governor in the history of the United States. He served 22 years as governor, and the only person that held a record close to his was the former governor of New York, who his name is Clinton, who was appointed by President George Washington. And so as a governor, energy is really important and jobs are really important. So this is a space that we're really interested in. Ambassador Branstad hosted Xi Jinping during his first trip to Iowa in 1985, and he's known him for a long time, and that's why he was chosen to be the U.S. ambassador to China. Unfortunately, the ambassador could not join us today, but because he's so impressed with Arthur's work, he wanted to share a greeting in the form of a message, and so I'll play that now.
Through our work with Arthur Lee, Steve and I have learned that during this dynamic period of time, SAI has introduced a new pattern and a creative vision in terms of how technology in the IT industry can be applied to change our traditional mode of heating, a development that has the potential to revolutionize the energy sector and enhance our quality of life. By reducing our dependency on fossil fuels, SAI transforms the old concept of mining to a new solution that powers a green transition for data centers in the United States and around the world.
All right, thank you, Arthur. Really excited to be here.
Thank you, Mr. Churchill. Yeah. You know, for Chinese people, Churchill is a really famous name. but not Prime Minister in London, yeah. But really important. Yeah, I think, and also I will introduce all the guests, and also here is JP, the partner of Jack, and he's already our consultant for SAI, and he gave much efforts and help to our business to extend in North America. So maybe in the networking time, if anyone want to talk about the details of the cooperation of opportunities, you could find me, find Jack and Patrick and our team member Jason. Yeah, we are all here to talk with you about the cooperation. So next, I will just start the speech, and please forgive me my Chinglish. Yeah, so sometimes you may feel confused, but Chinese logic is really different. But I promise that I won't mix desert and dessert anymore. Yeah. So the first part of my speech is about a deep dive into Bitcoin heat and its recovery potential. For Bitcoin industry, for trading industry, we saw Coinbase listed on Nasdaq, There are so many exchanges like Binance. Trading market is really, really big. And even the institutional investors just join the trading track. But for the mining track, maybe 2 years ago, there are some companies like Mara, right? They just buy a lot of mining machines and just order too much electricity. And after that, some people start to worry about the energy consumption of our industry. So yeah, there are so many voices here, just like New York City, they just released a policy to ban the traditional Bitcoin mining. For the whole New York State, they just banned the traditional Bitcoin mining based on fossil fuels. So yeah, I don't know whether there will be more policy or regulations about for the Bitcoin industry. So as a player or as a company, we just in this industry, we need to try to find some approach, find some solutions to figure out whether we could save the energy and make the Bitcoin mining clean. So that's our purpose. And actually, we find that. And we think that that will be a great way, not only for our industry, but also for the total computing industry. That will be great to solve the energy consumption and the carbon emission problems. So next, I will just show two pictures, really interesting. I think someone saw this picture before. Yeah, the left picture is from the Forbes News in 1999. At that time, I just a 6-year-old boy, yeah, so I didn't see this picture before. But I found on the internet, so that's a really good picture. And picture said, dig more coal, the pieces are coming. And the writers, he worried about the energy consumption for Amazon, because he think that when Amazon released more electric books or e-books, and people will need to consume more coal, and that will produce more energy, produce more carbon emissions. So is that worried right? I think yes, maybe, but I don't know whether after 20 years the writer still worried about this. I don't know, but I think yeah, it's really same as after 20 years, people start to worry about the energy consumption for Bitcoin mining industry. So we need to find the essential of the computing industry. Why we need use chips, why we need computing to deliver information, deliver value, why we need to choose that. Why not just still use the paper, use the car, use the transportation, use other ways to transfer our value, transfer the information. Why not choose that? Because I think there will be some trend. Yeah, that we need to find that trend. And the second picture is really, really important. When I set my our company SAI, I don't see this picture, but I just got into the Bitcoin industry, and I found Bitcoin is really interesting. But how could I join or participate in this industry? I think trading is not good for me because I just I'm not a good trader. I always lose money when I trade Bitcoin. So I just give up. No trading, just a hold. Yeah. So after I choose to hold Bitcoin, and I think that I just learned energy and environmental engineering in one of the top universities in China, but I dropped out. But yeah, dropped out. So that may be just a big. That's why I see some changes because I don't learn much English in my college. And after I dropped out from the college, I choose to find some industries that has connection with energy industry, but do something different. Yeah, so for my classmates, they choose to work for like boiler company or air conditioner companies. So I think that's really boring. I want to do some new thing. Yeah. So I think why not choose something new but has some connection with the energy industry. So I know Bitcoin, and I know Bitcoin mining use much electricity. So at that time, I choose to do something to find out whether I could solve the problem for chips, to help the chips to give them a better cooling system, and then maybe reuse the heat. So that's the beginning of our company. And after we finished that, and we finished our engineering pilot, the first pilot of our company, and we found that it's possible. We could provide liquid cooling for the chips, and at the same time, we could reuse heat. And during that time, I read the books and I read Bitcoin talk. I want to know all the sentences that the founder of Bitcoin, Satoshi Nakamoto, he had said. And yeah, by accident, I found this really interesting. He talked about the Bitcoin mining energy consumption problem. And he said that the heat from your computer is not wasted. If you need to heat your home, you are using electric heat where you live, and when your computer heat, it isn't a waste. It's equal cost if you generate the heat with your computer. Yeah, he said that, and he predicted that. And also he said that if you, at the last day, he's saying that Bitcoin generation should end up where it's cheapest. Maybe that will be in cold climates where there's electric heat, where it will be essentially free. Yeah, so it's really interesting. You know, look at the time, the 2010 and August 9th, the same day. Yeah, actually the same day. So that's why we choose to put this day at Bitcoin Heat Day. Yeah, because 12 years ago, the founder of Bitcoin, Satoshi, he had predicted that he thinks Bitcoin mining will be heating reuse scenarios, and that will be the cheapest scenarios. So he gave us the direction, but yeah, actually, when I said the company, I don't know this direction. But I think, yeah, we know that, and all of our industry, we should concentrate on this direction. Because actually, in physics, it's really easy because all the chips are resistors, just the same resistor you use in the electric boiler. So the efficiency is actually the same. Just 100% of the electricity put in, and out will be the 99% of the heat. So the efficiency is really, really close to traditional heater. So why not reuse heat? And at that time, if you reuse heat from the chips, and before that time, you may need two parts of electricity, one part for heating, another part for computing. But now, if you could reuse all the heat, maybe you just consume one part of electricity. First, computing or mine, then reuse heat to provide heating services. You save one part of energy. When you save one part of energy, you will save one part of carbon emissions. You will solve the carbon neutrality problem and challenge in essential way. So that's why I put these two pictures here. Really interesting. And maybe I think to put another news about the Bitcoin mining energy consumption worry. But I think, yeah, just this picture is enough for our industry. And about this whole picture, and I need to introduce some backgrounds of these three industries: heating, electricity, and computing. These three industries is really important for the modern life, for the modern society. And you know, all these three industries is based on energy. Yeah, actually they are all energy industries. So you know why I choose to study energy and environmental engineering in Georgia University? Because I think that energy is the fundamental of our society. Even agriculture is an energy industry because they need solar power. And in other industries, they need electricity or fossil fuels. And even computing industry, their capex or their OPEX mainly comes from electricity and the heating cost, the cooling cost. So all these industries, I think that their fundamental is energy industry. So I want to know how much energy they use in our society and how much carbon emissions they produce for our society. And at that time, we will know how big the challenge is for our society to realize carbon neutrality in the next few years. So first about the heating industry. Heating industry is really traditional industry. I think there won't be any changes in the recent 100 years. Just use hot water, use steam, use gas, use coal, and maybe some of them use the electric boiler. They don't change. And everything is really traditional, and they can't make much profit. So for the heating industry, but actually heating industry, 50% of the energy consumption for the society is used for heating industry. Like the power station based on coal, actually they just turn to heat steam, then empower the turbine, and then get the electricity. And also greenhouses. And also people who live in the north area, like New York, we need heating services in winter, maybe 4 months or 6 months. We need that. And also the greenhouses, we need fresh food in winter, and also some industrial use, maybe some companies, they need hot water, they need steams. So heating use is really the biggest part of the energy consumption. And it contributes around 40% of the carbon emission for the society. So this part is really traditional, but really hard to solve. How to make heating industry clean is a big problem. So I think that's why I can't see so many people to solve the heating problems about to realize carbon neutrality, because it's really difficult if you can't find a solution. You can't find a good way to make profit and at the same time use clean energy to provide clean heat. And second part is about electricity. For electricity industry, you know that we just advocate, the whole society advocates clean energy, like solar power, hydropower, wind power. But for now, 63% of the energy generation is from fossil fuels for the electricity industries. So nearly, I think, more than half of the industry just also based on the fossil fuels. So it's not sustainable, right? So we need to use more clean energy like hydro, like solar power, but it's not stable. The clean energy is not stable. So how to solve this problem is a long-term strategy. You need to build more clean energy power station first, and you find the good customers to use the idle energy. And when the energy supply is enough, and through the grid, they can just change the whole game and based on the clean energy. But it's a long-term strategy. So before that, if you are a clean energy owner, you can't make enough profit, or you can't get back your primary quick because you can't find stable customers. Yeah, at day night, like solar power, yeah, when the sun rises, yeah, you got power, but when sun sets, you don't have the power. So that will be a problem. And for the computing industry, it's the same. These two data is really important because most people will ignore this part. All of us know that traditional data center like IDC, owned by Google, Facebook, other big companies, their data center. Actually, last year they used around 260 terawatt-hour electricity. But they take around 50 years to develop to this level. Because when the computer released and when the internet released, yeah, we take 50 years to use this much energy for 1 year. But what about the Bitcoin mining industry? Last year, I think we used around 100 terawatt-hour electricity last year for Bitcoin mining industry. And you know, the Bitcoin just released around decades ago, around 12 years, I think. And the Bitcoin mining industry just developed, I think, around 7 to 8 years, I think. But it only takes 7 to 8 years to develop this big capacity, and even just comes to half of the traditional data centers. So that proves that the market needs that. Because if the markets, the whole world don't need Bitcoin mining, they can't get this kind of speed. But at the same time, the problem is all this energy from the data center, from the Bitcoin mining, they use the electricity and they need to use additional energy to do the cooling system, to finish the cooling test. And all the energy, all the electricity turned into heat. So before our solution, we need to find a good way to solve the cooling system. But why not change the direction? Why not use the heat? Because you see this, we need much more heat services around the world. Why not save this part of energy to reuse the heat from the computing industry to provide heating services for the heating users? And I will give you another important data. Just use Beijing. Like, you know, Beijing is cold in winter, and some of you just visit Beijing, I think. And the heating needs, the heating area for Beijing in winter is around 900 million square meters. That's really big, but I think New York will be bigger than that for the heating needs. And if we gather all the heat from traditional data center and all the Bitcoin mining companies, we gather all the heat, and to provide that heat to satisfy the Beijing, the heat needs, heat demands, we only can satisfy 70% of the heat demands in Beijing in winter. So through this data, you will know how much energy we need for heating need. Yeah, the heating and industry needs so much energy to get the heating services. And you know, through this data, there will be a big space for the computing industry, not only the Bitcoin mining industry. That maybe before that, we just need consume additional energy to provide for the computing industry. We need to consume additional energy. But now, we just use the energy that is used for heating needs, the electricity. So at that time, we will save the energy. We will save the carbon emission. And we will have a much bigger space for the computing industry to develop in the future. Because I think for now, you can see the numbers that the electricity we generate a year, only 1%, around 1% of electricity is used for data center, for computing industry. But I think in the next 10 to 20 years, this number will come to maybe 15% of the electricity will be used for computing industry. And I will tell you why later. So that shows that there will be a big space for us to develop. But how to realize that? You know, before we just put this solution for computing industry, they just based on, like Google, they just near the big city because they want to near the users. And for Bitcoin mining data centers, they need to near the power station because they want to save the energy loss. And for heating, they just near the houses, near the buildings, near the greenhouses. Yeah, they are totally different location. But in the facility, you need to invest 2 parts of facility. 1 part for heating. Like if you use electric heater, electric boiler, you need to put the same amount of transformers, the cables, and the substations, and also another part for the computing data centers. You need 2 parts of facility investment. So is there any potential that we only invest 1 part of electricity facility and provide services for the computing industry, for the data center, then gather all the heat as much as we can to provide heating services for the heating users. So if we could realize that, we will save the energy. And no one will just argue or against us that say that we just waste energy, we just produce more carbon emissions. Yeah. So that's the direction we found from the whole industry. And here's just an equation, really simple equation about the computing process. Yeah, I think that the computing process is just electric plus data through chip and algorithm, and then you get a value, and you get waste heat. It's really simple. And in this equation, there are only 4 parts of cost for computing industry: electricity, heat, like cooling cost, and chip cost. You need to buy the chips, buy the servers, and algorithm. A better algorithm, a better like cloud, will save your time. And all the industry players, they just concentrate on this part, the electricity. Yeah, they want to find the cheap electricity as cheap as they can to lower their cost. But for the electricity, their production cost is really close to others. Like American, like Asia, their electricity cost is really close to each other. And you can't find electricity that the price of the electricity lower than their cost. Yeah, they can't make profit. But someone here use liquid cooling technologies. When you use liquid cooling technology, yeah, it's high efficient. It has higher efficiency to do the cooling system. But you also need to consume energy. And you also need to invest more facilities, like liquid cooling system, like cold plate or immersion or oil, yeah, you need to invest more facilities. So the conversion, that's really important. From electricity to heat, as I said, is 99% because the chips is just the resistors. The efficiency is the same like traditional electric boiler. So why not to regard a chip as a heater? If you regard a chip as a heater, the next step is to how to reuse the heat from that. So really different direction from traditional way. So if we could reuse that, no, the cooling efficiency, why not heating? So that's our solution, and that's the problem we want to solve. And here comes some more data about the heating needs, about the electricity generation, and about the future. So chips enable electrification. You know, like transportation industries, we saw Tesla, a $1 trillion company. But you know, transportation only makes up 20% of the carbon emission for the society. So if we could reuse the heat and we could develop the computing industry at the same time, and we could save the energy, save the carbon emission, how much value we will make for the society. So here's the data about the 2030 forecast. I think the data shows that around 2030, the total power supply will around 40,000 terawatt hour. Yeah, we generate much more electricity than now. For now, it's around 20,000 terawatt hour last year. I think in the next 8 years, it will come to 40,000. And 6% of renewables. Yeah, all the countries, all the states, they want to develop their clean energy, their clean power stations. But I think maybe in the 2030, there will be 6% of the energy comes from clean power. And about the computing industry. The computing industry, I think for the Bitcoin mining industry, they will use 2,000 terawatt hour electricity per year, maybe more than that, maybe less than that. Just depends on the price of the Bitcoin, just depends on our technical development. And for the traditional data centers, they will use around 4,000 terawatts. Yeah, more and more people will use the digital way to solve their problems. And if we reuse 50% of the data center, 50% cheap heating of the data center, we could enable the needs and we could satisfy the heating needs like this. You know, at 2030, we think that the low temperature heat demand, what is the low temperature? The temperature around 60 Celsius degree. They need hot water for heating room or the greenhouses, just the low temperature heating demand. I think that will be around, based on the data, that will be around 10 to 20,000 terawatt hour. So if we could reuse 50% of the heat that we generate from computing industry, then we will satisfy at least 15 to 20% of the demands and no less heat demand satisfied, but just a switch to the clean power. And later I will show some project and I will tell you more details about the heating result and the heating efficiency. And also this is our one of our products. We call it SAI Hub. We just use liquid cooling technology to provide liquid cooling systems for the chips, for the PCB, for the computing industries. Then we gather the heat to make it just like traditional electric boiler, the same size, the same efficiency, and can provide the same amount of heat, use the same amount of electricity. So next I will show them. And also about the heating need and heating demands market. You know, for the heating scenarios, the biggest comes from the building, the community, because we need heating services in winter, make our house warm and make our factory, our warehouse warm. That's the biggest energy consumption for heating industry. And also greenhouse. We just use greenhouse because you know there are so many greenhouses in North America. And here's the data. How many greenhouses there? There are over 11,000 commercial greenhouses in operation in North America and covering 27 million square meters of land. And I think this data will grow up quickly because, when the life develops, we need more fresh vegetables. I need more fruits. Even me, I want to eat strawberries in winter. I want to eat watermelons in winter. Yeah, everyone wants that. We want fresh fruit, vegetables just near the New York City. I want that. Make it fresh, make it good, tasty. And I want all the fruits that I could eat in summer and I could eat in winter. So at the same time, people gather to the big city. So the needs for big city is really important. And if you want to satisfy their needs, you can't use transportation like railway, like airplane to transport the goods, but it's really expensive. So why not choose to develop greenhouses near the big city? And you could provide fresh fruit there. But if you want to develop greenhouses, you can see there, greenhouses typically use 2.1 gigajoule heat, or equivalent to 583 kilowatts hour of electricity per year. You know that they need much more energy. The greenhouses need much more energy. I just went to Illinois, and I saw there are so many plants growing on the ground, just the corns and other plants. But I know that in winter, the ground's just bare, no plants there. No one get the fresh fruit, get the plants in winter. And even the people there, they need to go vacation. They don't get any salary in winter. But if they want to develop greenhouses, the first problem they need to solve is about the energy consumption, the energy cost. And so greenhouses covering around 27 million square meters utilize 16 and 324 gigawatts hour, or 16 terawatts hour of electricity per year, and resulting in an annual utility bill of almost $1 billion. And remember this data. Now we just use 100 terawatts. And for the only North American greenhouses, and we need that. We need 16 terawatts hour, only for the greenhouses, not for the city. If we provide heating services for the city, just like I said, it can't satisfy Beijing's heating needs, so it can't satisfy New York City's heating needs. If we turn all the heating system in New York to centralized heating system and based on water pipe and based on electric heater, if we turn that, we need to solve the cost. We need to have a bigger electric heater, and we need to solve the problem of the cost. So the next part, I will talk about the major Bitcoin heat recovery technologies and players. Yeah, so today's topic is about the Bitcoin heat day. So I can't only talk about my company. I will talk about all the players in our industry to let you know what we have done and what is successful and what is failure and why they failure and what's the future. I want to share the opinion about that. Maybe I'm wrong, but we will just use our efforts. We will develop our products to prove that to the industry that we could solve problems like this, use our solution. So here's the technology involving timeline. It's really interesting, not like other industries, because there are not so many competitors who could reuse heat to provide heating services for now. And also, I just separate to 3 stages. The first stage is before 2018. Before that, there are 2 factors. The first is that the traditional Bitcoin mining machine, the mining rigs, the power of the mining rigs is around 1 kilowatts. 1 kilowatts is not hot enough. So you see that they just use the heat, use the fan to provide hot wind to the home and to the farm. But you can't do this in a large scale. It's not an industrial product. And after 2018, when Bitcoin released and largely used S9 and more advanced devices, the power of the mining rigs comes to 1.5 kilowatts and even 3.5 kilowatts now. When it comes to the more companies, more players, first they face the cooling problems because here there are so many miners here. We know that in summer in Texas, the devices will just stop because it's too hot. And also, there are some companies like this, they find different solutions for computing industry, especially GPU and ASIC chips. And they want to reuse the heat to provide heating services. Some of them just build a small heater for home use. For a home, for a family, they build an electric semiconductor heater for the home to make the home warm and to give the hot water for shower, just a small scale product. But they failed because if I'm a customer, I need heating services in winter. There are two choices I could choose. First is to buy a cheap and traditional heater, maybe just $100, maybe just $40. And the second choice is to buy a more expensive heater. But I will tell you that you could get back your money maybe in the next few years. Which one will you choose? I think I will choose the first one because I just need heat services. I don't want to make this so complicated. I need to calculate when I can get back my profit. It's really difficult. And for our industry, you know that like Google, they won't distribute their data center to small parts around the city. They just gather because it can help them to lower the cost. So gather and centralize will lower the cost. We all know that. So centralized and large scale will be the trend. So that's why my company, SAI, we didn't choose the direction to provide services, to provide products for the home use, because I think that it's low efficient. It's not a trend. And some of them just use the traditional mining rigs from Bitmain or what's miner, use the fan to provide hot wind inside the greenhouse. So the problem is that if you just use the wind, the plants near the machine will really hot. But the plants far away from the machine, from the wind, they can't feel the heat. So that will influence the revenue for the greenhouse owners. It's not good. The heating effects is not good. And so if we want to have a better heating results, a better heating efficiency, we need to use the water pipeline. We need to use the hot water and use the radiators and even the fan cool. So that's what we did before and what we did in the future, because we choose water, we choose the liquid to gather the heat, to transfer the heat. So we have a long distance transfer in the future. We could transfer the heat even more than 1 mile to the city and even keep it hot. Yeah. You know, so for now, I think that there will be some places that has a centralized heating system, electric boiler heater system, and we just replace it. It's really easy. But if not, they just have the traditional hot water pipeline, but they use the gas boiler, they use the traditional boiler. We need to build electricity facilities. That's all what we did before. And also, the third stage is this year. This year is really different because all the players in this industry, some of them just bankrupt and fail. Yeah, but yeah, maybe you can't see some of the company in this list, but we listed on NASDAQ. Yeah, so after that, we are the only company that focus on the Bitcoin mining and heating reuse and provide the solutions to help the whole industry to lower the cost and to try to reuse heat. So I think that will be another new era for the industry. We want to let all the people, all the investors, all the industrial players to know that maybe we could choose another direction. And for our company, we are very willing to open all of our technologies to provide services, to provide solution, to provide products. So here is the first site we did before in HR. And this is a side node in greenhouse. We use around 10 cabinets, around 2.5 megawatts. 2.5 megawatts computing server, and to provide around heating services for around 30,000 square meters for the heating space. That's the first pilot we did before. And here is the second and third project. We just provide heating services for office building and provide heating services for commercial, like hot water for the hotel, for the residents. And now we have our new side node in Ohio. That's a big progress for our company because that's the first pilot, the first project we did in North America. And that's really important for our company. I think that it's a really good demonstration to show how our systems run in North America. And I will show you a video.
SAI.TECH is proud to announce that it will begin operations this month at its new North American distribution center in Chesterland, Ohio, and activate its first SAI node project as a live demo of a sustainable Bitcoin mining and innovative heating equipment at its new facility. This 30,000 square feet facility will play a key role in SAI.TECH's expansion plan in the North American markets, including both United States and Canada. It will serve as the service and training headquarters, the final assembly, repair and distribution point. It also features the first SAI node project in US, demonstrating SAI.TECH's unique energy-efficient liquid cooling and waste heat recovery technologies and solutions, with a live heating application of a SAI Hub cabinet to the Bitcoin mining and traditional heating industries in North America, calling for consensus of Bitcoin heat. Starting from Chesterland, SAI.TECH is going to introduce and roll out its liquid cooling and waste heat recovery technologies and solutions to the North American market, where global Bitcoin miners concentrate. Human productivity is increasingly built on data centers' computing power, and SAI.TECH is redefining the future of our power, computing and heating infrastructure, improving the total energy efficiency across these three industries. At SAI, we're all energists.
So that's our first pilot in North America, and really, I think for me it's really amazing because, I saw so many mining centers and data centers located in desert, right? Desert, not desert, yeah. But this data center just based in the town, in the forest, and can provide the heating service for itself. It's big warehouses, provide heating services for itself, and at the same time, maybe in the future, provide hot water, provide heating services for the neighborhood. So that's really different location, a really different solution, and different electricity source. And also about the details. This side node inside that is in Ohio, and it's for now it's just around 1 cabinet, and in the future, in the next few months, we just extend it to 1 megawatts. And I will show another 2 videos, really good videos that our team filmed. And also, I will show more details about of our construction. Really interesting. Here. Okay, and these pilots will open for visit in the next few weeks, and all of you and all of the partners, the players, we are open for the visit, and welcome to join us to know about the details, how we run this system. And there's some economic benefits. I just make it really brief. You can save the construction cost, you can save the power consumption, you can save the operation cost, and also save the coals you need to use and save the carbon emission at the same time. So you replace the traditional heating system with the new semiconductor heating system. And about the invasion of world with Bitcoin mining and Bitcoin heat, I will talk more about the fundamental theory about this. Just like the Forbes News, people worry about the development of internet industry, and now people worry about the development of Bitcoin industry. So is that right to use the energy to transfer information and the value through digitalized way? I think it's right because I just think that mobility is the essence for the society because all the industry need energy. And I can see this in history. 100 years ago, like Standard Oil, the biggest company in the world, he just used pipeline to transfer oil and gas. So he connected petrol and automobile. And through that way, he realized cheap atom migration. You just move one goods from place A to place B, from city A to city B. You move the goods. Actually, you just move the atom. So, and 30 years ago, when computers developed, you just transfer information through digital way, through internet. At that time, CPU and chips and servers just connect electricity and computing. And at that time, you realize the cheap electron migration. And it's really simple because the atom, it has their mass. But electron, it can move fast, just the same speed as light. So electron will be faster to transfer information, to transfer value. So we need to, so digitalize is actually the trend because through digitalized way, we use electron to transfer information instead of use atom to transfer information. That will be save more energy. Like in the past, you just need to write the letter through the paper and to send the letter from New York to Shanghai. It takes a few weeks. It takes energy, it takes time, but now you only just tap words on your phone, just use WhatsApp. And your friend just get a message immediately. And there's actually no energy consumption, really, really small. So about 10 years ago, we saw this car, Tesla. Yeah, what's the problem he solved? Because he used battery to replace the traditional engine, and he connect electricity and automobile together, and he realized the clean atom migration because we need to move from place to place. So that's the EV realized. That's the problem EV solved. And what's the future? I think the future is that we need chips to realize the clean electron migration because atom migration, electron migration, and clean atom migration and clean electron migration. So when we know the trend that decentralized is the trend, that we can't stop. So we need to realize that to make the computing industry sustainable. So at that time, if you want to make computing industry sustainable, especially for ASIC chips and GPU chips, which industries that use much energy than before, than traditional data centers, you need to connect electricity and computing with heating. You need to integrate all the three industries together. At that time, you will save the energy. You will save the electricity facility investment, and you will save the cost. So there's our solution, just the same equation. The electricity, chip, algorithm, and heat are the 4 factors that we faced to determine the cost of a computing process. So we need to 4 parts to save the problem, like the heating problem, like the electricity problem, and the algorithm problem, and about the chips problem. We need some technologies. We need to do that. So that's what we do in our company. Just like there will be a car racing, but we won't start right now. We want to build a better engine. We want to build a Ferrari engine, make it faster. Then we just fill the oil, and we will run faster. Before that, we just build a better engine. If we don't build better engine, we use a not good engine, we will just waste energy, I think. Waste the capital, waste the energy. So I think that this solution will help us build a new cloud. Just like traditional cloud computing, software as a service, platform as a service, and infrastructure as a service, a traditional one. But for ASIC chips and GPU chips, for this kind of computing, I think there will be 3 parts: infrastructure, protocol, and service. So for the infrastructure, we need to use the electricity, reuse the heat, and provide the whole facilities together. Then for the practical, the Bitcoin and Lightning, just like the protocol, and the AI cloud is also the same. And about the service, just we need an open source, all-in-one application. Just open source and all-in-one. You could manage your asset, your Bitcoin, your hash rate, your heating services, your electricity bills. At the same time, you may use that to have the decentralized message services. And what's more, right? For now, we just build side node, just an integrated warehouse or pilot or project that we build a data center inside it and reuse the heat to provide heating services and save the energy, the electricity facilities. But if we extend the scale to a large capacity, could we just provide the services for a whole city? I think yes. If like New York City, like Beijing, like other city, you know that around the latitude north 40 degree, it concentrates almost 1/3 of the population for the world, like Beijing, Berlin, Tokyo, and New York, and Washington, D.C., and Chicago. All these cities, they need heating services, and they need fresh food. They need fresh vegetables. They need winter, they need warm, they need heating services. So why not build an ecosystem to provide heating services for the city and to provide computing services for the people in the city, and also to build a sustainable and a large-scale electricity facility at the same time and integrate that together. So at last, that's our name, why we call it SAI. We want to show that sustainable computing, available power, and innovative heating. These are 3 things I think in the future society, the people need in the future, all of them, we need that. We need a sustainable way to live a better life. And also, we are salute to 3 giants, Stephen Hawking, Albert Einstein, and Isaac Newton. So I wrote this in the book on your chairs named Energism. And I wrote that book and released on Amazon just to tell the investors, tell the market, why I think energy is the fundamental, why I choose to set up this company, and why I choose this direction, and what we will do in the future. And also, I'm a lazy man, so I don't want to talk times by time to different people, so I just wrote a book. You could read that to save my time, to save everyone's time. Okay, thank you. So that's my presentation and that's my speech, just to tell you more about information. Yeah, actually for heat day, I think maybe next year for the heat day, the fruits, the juice, the flowers, all the things is provided by ourselves. And we use the heat based on Bitcoin. Maybe we will just give all of you presents like strawberries and fruits and flowers. We will send to you and to mark on it that this flower, this fruit is based on Bitcoin's heat. And you could pay for that by Bitcoins. Yeah. That will be a real thing. You could touch, you could feel, and you could eat, and you could enjoy. But Bitcoin is digitalized, but there's something have connection with Bitcoin that you could feel that, and you could live better based on that. So that's my speech. And next, I will invite Patrick to show our ESG strategy and our views about the ESG trend, about the waste heat recovery.
All right, hi everyone. My name is Patrick Feldmeyer. I'm part of the ESG team at SAI. Thank you, Arthur, for a great presentation. So now I'll just talk a little bit about our ESG initiatives here at SAI. So we're kind of living in an age where data centers are expanding. They take up a lot of space, and they require, they're very integral in our communities today. And they use vast amounts of environmental resources. And as we go on in the next 15, 20, 25 years, they're always going to be a primary driver of our global energy consumption. This was also exacerbated by the onset of COVID-19, and there's always going to be an increasing need for global digital infrastructure in our world today. Now, with the global call for zero carbon emissions, data centers must have solutions in place for the decarbonization of data centers. So by leveraging a circular economy that Arthur mentioned earlier, we can systematically analyze data centers, control their mining and critical raw materials, and construct the best alternative for a carbon neutral world. So here's what I'm going to be talking about today. First, just a brief overview of ESG, and kind of going over how traditional data centers operate today. And then we're going to move into how SciHubs are sustainable, and how they will be sustainable in the future ahead. And then moving into waste heat recovery. So what is ESG? Obviously, every company's had it in their mission statement. They kind of just blanket over it, don't talk about it too much. But I think over the past 2 years, ESG has really become a chief concern for every company. What are we emitting into our society? How are we treating our employees? And how can we become a world-renowned company in the future today? And that is something very integral to SAI because our product, the SciHub, can have very, very positive or negative impacts on society. Now, so let's start with the current state of traditional data centers. They require vast amounts of electricity and output large amounts of carbon into our society. Fortunately, digital infrastructure has opened up vast opportunities to reduce waste heat and improve efficiency across many industries. Climate change has only increased this awareness as well in order to offset the current trajectory of pollution, high consumption, and the waste of natural resources. Data centers will always consume large amounts of electricity and energy. And in line with thermodynamics, every joule of energy pumped in through your computer ends up as heat one way or another. Now, for personal computers, you're really not going to notice this heat. But we have rows and rows of these data centers and all these servers. This heat can become a major engineering problem. Now, larger companies, as Arthur mentioned, are able to leverage efficiencies of scale to cut their cooling costs. But in smaller data centers, cooling can account for up to 50% of the electricity used. So here's where we are today. So looking at sustainable data centers like the SciHub, they all use their resources efficiently. And one thing about the SciHub is that using AI, any given time of the day, you always know what the data is saying. And if there's something wrong with the data centers, and that's what makes these SIBs very, very efficient. Now, they're also designed and built to reduce embedded climate and environmental impacts. So applying these circular economy principles, waste heat recycling and water recycling, using sustainable building materials and processes to reduce embodied carbon, such as lower carbon concrete. These are how these sustainable data centers can really replace the existing data centers we have today. And then by relying on clean and renewable energy resources, increasing reliance on renewable energy generated on-site and off-site, and then aligning renewable energy supply with demand through time-of-day workload optimization, and then by utilizing fuel cells as a cleaner energy source of primary backup power. So looking at really 90% of all companies today, they've really updated how much effort they're putting into ESG, and then how sustainable their operations are going to be into the future. 89% of organizations say they prefer to do business with a partner that shares similar sustainability goals. And 90% of the S&P 500 index companies publish sustainability reports. And 87% of organizations include data facility metrics in corporate sustainability reporting. Now, most companies are on a path towards improving sustainability, but each is progressing at a different rate. Varying local, regional, and country regulations and expectations make it difficult to progress in all areas where business is conducted. And macroeconomic trends in the oil and gas industries may make renewable energy investments attractive in the near term, but companies should also always pursue long-term solutions. So here's where we are today. Data centers and other publicly traded companies are becoming increasingly transparent in sustainability operating. And nonprofit organizations have been formed to promote education on how to purchase and deploy renewable energy on-site and off-site, paving the way for progress across all sectors to buy renewable energy in places not served by cost-effective local solutions. And then regional, state, and local governments are pushing for change as well. Thoughtful, long-term planning processes are being established within a focus on businesses, contributing positively to society and helping to address large-scale problems such as climate change. So what is waste heat recovery? So waste heat recovery is the use of thermal energy that would otherwise be transferred to the environment to accomplish a useful function. In many cases, waste heat recovery avoids or reduces the need for additional fuel energy input that would otherwise be required to achieve this function. Examples for internal combustion requires include heat exchangers, turbo compounding, bottoming cycle, and thermoelectric generators. Now, using Sci-Hub as an example, carbon emissions from data centers are down as major players in the sector move to using renewables, and advances in efficiency have brought data centers' energy use to a plateau, even as the amount of storage available increases. Now, some of the most innovative technology companies are turning something that has historically been a liability into something that's an asset, using the massive amounts of heat generated by the servers. So instead of using electricity to cool these data centers, a handful of companies are at the forefront of efficiency, are capturing that waste heat and using it to defray energy use elsewhere. Now, not only does this reduce cost and carbon emissions, it has an appealing elegance. The elegance could come in handy as data centers fight the perception that they are the best, at best, ambivalent toward, and at worst, harmful toward their surrounding communities. An elegance that can drive higher multiple uplift as sustainable Bitcoin companies are compared to their peers. For example, like SciHub Solution, SAI has successfully deployed a pilot operating center in Central Asia. The Sci-Heat Energy and Computing Center can use technical means to recover the waste heat generated by computing, and then use the heat for greenhouse heating. The greenhouse can be maintained at 31.5 degrees Celsius. The outdoor environment is minus 20 degrees. The average heat recovery of the whole process exceeds 90%, so it's highly, highly efficient. Now, obviously, data centers are not all the same. Strong investment in renewable energy by the data center sector is driving the uptake of renewable energy globally. Renewable energy power purchase agreements rose to 9.33 gigawatts in 2019. and this shift is having a positive impact on carbon emissions. And using cleaner energy is key to progress. But within the sector, it is also important to address the energy wasted throughout the inefficient use of power. So by improving utilization rates through the virtualization software-defined infrastructure goes a long way to improve energy use. So here's how SAI is handling the environment. We will support the measures and targets outlined in every country's climate action plan the SAI operates in. We will support the PPA model, facilitating the development of renewable energy generation infrastructure. However, believes that in the long term, other potentially off-grid solutions need to be examined, developed, and implemented. And SAI-Node and SAI-City ideally suited to facilitate the creation of a long-term, sustainable solution to energy storage of a source of large-scale renewable energy, plus a national grid connection. Now, in terms of sustainability, waste heat from the DC and from the chip generators would be used to facilitate the AD process and to dry the byproducts to produce valuable fertilizer for agriculture. And cleaning the gas for injection into the gas grid produces quantities of CO2, which should be used to help establish greenhouse fresh produce operations, also located on the data center campus. Now, in terms of ethics and integrity, SAI is committed to honesty, integrity, and fair play. And in all its dealings, it will be open, fair, and impartial. Now, these principles guide the company when it's faced with legal and/or ethical decisions, and in facing those decisions, seeks resolutions that embody the principles. Obviously, SAI was just going public a long time ago. By establishing this culture, it's the culture of success that will make SAI very successful in the future ahead. Now, in terms of governance, at SAI, we believe that high standards of business conduct and corporate governance are essential to the successful and efficient running of our business. Strong corporate values are essential to how we support our colleagues and customers as we drive innovation in our infrastructure and our business models, investing in becoming a market leader in providing sustainable and ethical data center ecosystems. Our board is central to our strong governance ethos and is tasked with oversight of our commitments to the ESG agenda. Now, we have policies in place to ensure that a diverse candidate is developed for new hires as the organization grows. We believe that respecting the environment is a social imperative. We have a key role to play in solving our customers' sustainability challenges by embedding energy efficiency and sustainability throughout our data center offerings. And SAI's stated ambition is to lead the industry with policies, programs, and solutions that reduce our customers' environmental impacts, helping them to reduce their carbon footprint and achieve their short, medium, and long-term carbon reducing goals. Now, for the environment, we ensure a positive impact on climate change. For social, we promote innovation that all companies can build off of. And for governance, we ensure that our technology is safe and compliant. Now, overall, SAI.TECH provides all key users with the opportunity to benefit from lower costs and a healthier world. We invite you to make a positive step with us in that direction. Thank you.
Thank you, Patrick. And yeah, that's the second part of this event. And we come to the third part. The third part is the time for all of you to do the networking, and you need to talk about the cooperation or anything else. You could just feel free to do that. And also, I will mention that outside the door there will be fruits, juice, anything that you want. Yeah, you can choose them. All healthy. Maybe I think much healthier than pizza, right? So choose that, choose the fruit, and we could just start our networking. Thank you for joining the Bitcoin Heat Day. Thank you, everyone. Thank you. Okay, so everyone can choose that, and I will just let the guys in, and he will help us to move some chairs out, so we will get more space, and everyone can have the space to talk. Yeah.